Good morning, everybody. We're gonna start today part 3 from our lesson similarities. We're gonna deal with the 3D shapes here. We have the first prism P with cross-section area. It's given for me that the area of the cross-section equal to 10 centimeters squared. So this is the first area for this shape. I don't have the area of the other shape. I have only length given for us, which is equal to 6 centimeter here and 12 centimeter here. What they asked me to find, they asked me to find a volume of the second shape. This is what I need to find. Directly I can get the volume of this shape. I know that the volume of this shape is the area of the triangle multiplied by the length. They give me that the area of the triangle, which is the cross section, they give it equal to 10 centimeters squared. So I can directly multiply it by 15 to get the volume of the first shape. So the volume I'm gonna say now, it's 10 multiplied by the length, which is 150. 1.5, sorry, it's equal to 150 centimeter cube. So I got now the volume of the first shape. To get the volume of the second shape, what I'm gonna do, I'm gonna apply my rule, which is volume 1 over volume 2 equal to side 1 over side 2, but all to the power 3. In this case, I'm gonna get volume 1, which is equal to 150. It's over volume 2, and this is what I need to find. I'm gonna get it equal to side 1 to the power of 3, which is 6 to the power of 3, over side 2 to the power 3, which is 12 to the power 3. And if I'll solve for this, I'm going to get 150 over volume 2. It's equal to 216 over, I'm going to find now volume 2, 12 to the power 3, which is equal to 1728. And by making cross multiplication, I'm going to get the answer equal to volume 2 equal to 1200. Remember to put the unit centimeter cube. And that's it. This is how to find the volume from the given area. Remember, every time if we have any shape, let's say if I so anytime if we want to get the volume of the shape, I need to take the cross section and then multiply it by the length of this shape. Let's say if we have a rectangular prism like this, I need to get the area of the cross section, which is length times width. I'm gonna multiply it by this length. I'm gonna get the volume of this shape. And even if we have cylinder like this, and I need to get the volume of this shape, I need to take the area of this circle multiplied by the height, or I can say the length of this shape, because if I want to cut this shape into many pieces, let's say, I'm gonna get every time circle. So this circle multiplied by the height or the length of the shape, I'm gonna get the volume of this shape. Even if we have cube, we know that the rule to find the volume of the cube every time it's s to the power 3, and we are getting this from the area of the cross section, which is the area of this shape, which is here area of the square, which is s squared, multiplied by the length, which is s. That's why we are saying that the volume is equal to s to the power of 3. So if you have the area of the circle, and if you will multiply it by the height in this case, you're gonna get the volume of this shape. And if you have the rectangle area and you have the length of this part, I'm gonna get the rectangular prism area. And this is what we are using every time to get the area or the volume of the 3D shape. Thank you. Cross section times length. So this is the second question for part 3 similarities. They give us the diagram shows two mathematically similar containers. The larger container has a base with diameter 9 centimeters and the height 20 centimeters, and the other one with d centimeters and the height 10 centimeters. They want me find the missed part, which is d. According to this, I'm gonna say also 9 over d equal to 20 over 10. But before starting all of this, we need to check that all the units the same centimeter. Now by making cross multiplication, I'm gonna get 90 equal to 20d. So if I'll divide each side by 20, I'm gonna get d equal to 4.5. So I got now the first part in our question. I'm going for the second part. The larger containers has a capacity of 1,600 milliliter. We need to know that the milliliter mean, or 1 milliliter mean 1 centimeter cube. So anything here, I need to cube it to get the missing volume or capacity or something like that. Now, if they give me for the big shape, the capacity 1,600 milliliter, and they want me find the other one, so I'm gonna put it over each other. I'm gonna take one length of the first shape, the big shape here. Let's say I'm gonna make it 20 over the second one, 10. Remember, I need to make it to the power 3, as what I told you before. I'm dealing here with volume, capacity, 1 centimeter cube. So in this case, I need to cube this part also. So I'm gonna get now from this part, I'm gonna get 1,600 over x. It's equal to 8,000 over 1,000. And if I'll make cross multiplication, I'm gonna get 1,600 multiplied by 1,000 divided by 8,000. I'm gonna get the answer is equal to 200. So this is what I need to find as an x, which is the capacity of the second part. Thank you. Okay, what about if we have ratio in the question like this? Two similar vases have a height which are in the ratio of 3 to 2, and the volume of the large vase is 1080 centimeter cube. Calculate the volume of the smaller vase. Okay, now I have ratio. This ratio, it's mean the scale factor. I'm gonna put it big to small, 3 to 2. So this is big to small. This is what I need to use now. Big to small, 3 to 2. The volume of the large vase is 1080 centimeter cube. So in this case, I'm gonna say 1080 over the volume of the other one, which is the missed one, volume 2, let's say. It's equal to 3 over 2, but you need to put it to the power 3. So now the same thing, 1080 over V2, it's equal to 27 over 8. And by making cross multiplication, I'm going to multiply 8 times 1080. Then I'll divide it by 27 to get the answer. So I'm going to get the V2 equal to 320 centimeter cube. So for the surface area of the smaller vase is 252. So the small one has an area, surface area equal to 252 centimeters squared. Calculate the surface area of the large vase. If I want to find the surface area of the large vase, I'm going to use the same thing, also the scale factor, but it's to the power of 2. So I'm going to say area 1, which is unknown, equal over 252. It's equal to 3 to the power of 2, or to the power of 2, 3 over 2 to the power of 2. So in this case, I'm going to get A1 over 252 equal to 9 over 4. And also by making cross multiplication, I'm going to say 252. I'll divide it by 4. I'm going to get the answer, area 1 equal to 567 for the big shape. And that's it. Thank you.